Hi, I'm Dr. De Bruin, and this is a walkthrough of an A-level chemistry exam question from the transition metals topic. Let's get started. There are three parts to this question, but it's actually quite a nice question because it leads you sequentially through the exam board's thinking, and so you kind of have some clues as to what it is that they're wanting from you. So we start off with some electron configuration. So this is nice and straightforward. You've been doing it since the very start of year 12 in the atomic structure topic, and as long as you don't make any silly mistakes, it's kind of easy marks in the bag. So firstly we have this copper atom, and the electron config is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. So you might be familiar with this as the copper and chromium rule, or you might call it the 3D rule, but it's this idea that atoms are more stable when they have either 5 in the case of chromium or 10 in the case of copper electrons in their 3D subshell, rather than 4 or 9 respectively. And the way that this is achieved is by relocating one electron that you would expect to find in the 4s subshell, which is filled first, into that 3D subshell instead. I should also mention that it's fine if you would rather write the 4s and 3d the other way around. Personally, I prefer to write them in the order in which they fill, but it's fine if you want to keep your 3s and 4s together. Then if we look at the 2+ ion, we're going to have an electron config of 1s2, 2s2, 2p6, 3s2, 3p6, 3d9. So although the 4s subshell fills first, it also empties first. So we lose that first electron from the 4s subshell, and then the second electron is lost from the 3d subshell. So we end up with 3d9. Now, going on from that, this gives us a little bit of a clue that the reason that copper is a transition metal is because when it forms those 2+ ions, it has an incomplete 3D subshell. And then this leads us quite nicely into the final part of the question, which asks us about characteristic features. And it doesn't actually say transition metals, but the previous question has given you a clue about this. So the first thing is that transition metals have variable oxidation states. So for copper, it's 2+ and 1+. And those oxidation states tend to be associated with different coloured compounds. So you're really familiar with copper 2 sulfate, copper 2 hydroxide, and how they have that characteristic blue colour. But actually, it's not just the copper sulfate that has that blue colour, it's hydrated copper sulfate, because of course transition metals also form complexes or complex ions with ligands. So when you think about that blue colour for copper sulfate, you're really thinking about the hexa aqua ion, which has those 6 water molecules associated with it as ligands. And then finally, because of those changes in oxidation states, transition metals are often very good catalysts. Thank you very much for watching, and I hope that you are finding these walkthroughs useful as part of your revision. If you are, then don't forget to like and subscribe, and also let me know in the comments which topics you'd like me to cover next.